Today I'm pretty excited to finally do this custom drone build, which for the most part has some compatible parts, like the frame that you see right here, the 2.5-inch SpeedyBee frame, and the all-in-one flight controller. The mounting for that at 25 millimeters is all compatible with each other, but every other part is essentially made up on the fly. I really enjoyed being able to put this thing together, take it apart, and you'll see how we are now making a one-of-a-kind drone that is the best of all worlds, and we were going to do the whole thing today. Something I didn't understand when I got into this is that the 2.5 inches actually refers to your propellers that you can use with the frame and not the frame itself. First thing to do is this expansion board. So there is a 25.5 millimeter mounting on that little purple chip that you see there. This expansion board that you see at the bottom of the drone allows us to kind of extend that. It does one thing: it moves the USB-C plug for programming and that kind of thing to somewhere that's really accessible, which is obviously easier for when you're in the field. It's just annoying to get into your frame and underneath that chip to plug it in. So that's just convenient, as well as changes our place for those power outputs. So now we'll have an XT60 plug instead of having to solder something directly to the flight controller. Gives us a little more space for the flight controller itself, as well as, well, it's just more convenient and we can locate our battery somewhere a little bit better. The board will also handle the 9-volt and the 5-volt power differently than if I were to just plug and play it on the chip itself. So this is a really vital piece, and I'm glad that SpeedyBee made something like this. Even in my experience as a Bixby tech, I didn't do a lot of soldering, so this is new to me. I've learned some things, but I want to go over the basics. So essentially you apply flux, which is kind of like a bonding agent. It makes sure that the tin from your wire is going to solder to your pad, and you'll actually get a good connection when you apply the solder. So you want to make sure that everything that you're going to attach to each other has flux on it. Super cheap. You can get it anywhere. The actual iron, you want to make sure that you have the right one. You'll see somewhere during this build I actually swap it out, that it wasn't quite hot enough for the solder that I had. It should be more than 325 degrees Celsius, but you want to check which solder you have against which soldering iron you have. Just make sure ahead of time. Now, the most important part is that you want to hold your iron to the pad and not to the solder. You want to heat up what you're going to connect to and then push the solder into it and apply it. And that will give you a far better connection than if you were to try to melt the solder onto the iron and then push it off onto your pad. When you're thinking of where to strap your battery to, we do have it as part of a kit onto the backside, which is very normal, but you have to think about where you're plugging it in. You want it to be tight and easy to access, so you can remove the batteries, change them out, but you also want to make sure that your plug and your cable are long enough and they can be plugged and unplugged 1,000 times and not be overly difficult. The most important part of the drone is not the motors, but everything stems and works backwards from them. So I'm going to kind of explain what I mean, but so we have 3800 kilovolt motors. Now, when you choose motors, I'm going to lay out all the math for you. So you use P equals IV, which is, if you remember, freshman year physics or whatever, power equals your amperage times your voltage. So you'll take your amps, multiply it by your voltage, and that will give you the wattage, or the total power draw that your system's going to pull. Every motor will be slightly different, but when you order it, it will tell you. So the F1404 at 3800 kilovolts is going to pull 12 to 15 amperes at normal operating and at its peak. So 15 amps times 4 motors, now that's 60 amps. So you have to make sure that your board, your all-in-one flight controller, is able to handle that. The all-in-one is really nice because it puts the flight controller and the electronics controller together, and this saves on a ton of weight. But it does put a lot of components in one place. And so if you don't do the math, like, hey, can this handle 60 amps? I don't know. And you end up messing that board up, which I've done before, that would be a problem. But the payoff is that you save 30 to 45% of the weight. It's only 8 grams on our build, but when you're trying to stay under 250 grams, because if you don't know, Part 107, to be a Category 1 drone, you have to weigh less than 250 grams total with everything on it. So it may not necessarily matter to my build right now, but a lot of you watching this, especially once you get close to the 250 limit, or if you're working with a different category of drone, it will. I'm a registered Part 107 licensed commercial drone pilot, but if you stay under the 250 grams weight capacity, you do not have to register your drone with the FAA, and that just, it just lets you have fun and not have to worry about it. Motors aren't too tricky. The electronic board converts the signal that your power is getting to what mimics AC on 3 different wires for your motor. That's why it works with DC power, and I'll explain that in a little bit. But it does not matter the order that you connect these 3 as long as they're connected to the right pads, and you're also cognizant of which motor is on which set of pads, so that way when you program it, you can change things around. Now that you know your motors are compatible, you also want to make sure that your all-in-one, it will be rated for the amperage draw. So mine is rated for 25 amps per ESC, and each one's only ever going to pull 15. So I know I'm good. Now, if you take the full 60 that it's able to do, multiply it by the voltage in your battery, which in my case is 14.8, that gives me 888 watts of total power that I can use on these motors. And then I can calculate how much flight time I'll have, and if I'm doing more or less aggressive maneuvers, where all that power is going. It's just nice to know ahead of time, and that's how you do that math with P equals IV. We're going to move on to our ELRS receiver system. It's a 2.4 gigahertz receiver, which means that that's what it receives from our radio when we actually use the controller to give it inputs. So the entire thing works like this. Your ELRS will receive a signal at 500 to 1000 hertz, whatever it's rated for, which means that it will receive one command per, it's 1 second divided by that number that I just gave you. So it will receive one command every 1 to 2 milliseconds, which is why your input is so good. The higher that number, the better. So as you move your input, it will encode it onto whatever your receiver is, which I mentioned is 2.4 gigahertz in my case. It will transmit that, and then it will receive it on its own language, which is what's called a protocol. So the protocol for mine is CRSF. An old analog one that I used to use was FR Sky. That's where that comes from. It's the language that the receiver uses to communicate with the flight controller. When the flight controller receives the signal, it deciphers it using this protocol and then tells the ESC what the input is, so that way it can deliver the appropriate amount of power to each individual motor, and that's how the entire process is from start to finish. Motors take AC and your battery only delivers DC. The workaround for this is that your ESC actually flashes your electrical signal. Your electricity actually turns on and off super fast using a MOSFET, and it mimics AC voltage. That way you don't actually have to transfer it from DC to AC on board. The trickiest part about wiring this stuff up is making sure that one system works with a completely different system. So it's not always going to be straight across. You got to make sure that the wiring diagram for your ELRS in this case, its transmit, it receives, its voltage, and its ground goes to the appropriate pad on your all-in-one or your flight controller or whatever. With the frame kind of finally laying on the insides of this drone, it's actually starting to come together, and I think at this point I'd spent about 4 hours on it, but I am learning along the way. This shouldn't have taken me this long, but I really am not very good at soldering. I didn't fully understand the wiring diagram, and so I've learned a lot along this process, but I'm just saying this because you really don't have to understand everything all at once when you order the parts. You might end up getting the wrong part, you might end up doing it wrong, but you can go back and fix it. So if you want to do something like this, I would highly recommend not having to worry about all of this stuff that I'm explaining to you, because I did learn most of it along the way. One of these things that I've learned along the way is how to appropriately size your batteries. So if you have a battery and it has, let's say mine is 650 milliamp hours. If that's just normal amps, that's 0.65 amp hours of battery life. Now, in order to tell how much amperage draw you can actually pull, you multiply that number, once you convert it to just an amp, 0.65, you multiply it by your C rating. Now, this gives me 45.5, which means that my entire ordeal can only pull 45.5 amps from the batteries that I've bought. Now, I actually did the math, and if you remember, it can pull up to 60 amps. So the workaround for this is called the OSD, or when you go into something like Beta Flight Configurator or anything that allows you to mess with the programming of your individual motors, you can cap their allowable draw, and that's how you stop from damaging your batteries. But if you don't size things appropriately ahead of time, you have to do that on the back end and make sure you don't damage them. Something you want to be very cognizant of while you're doing your drone build, or even when you're pre-planning it, is wiring. So, I mean, you can tell kind of by the gauge of wire that you want to use. Most of it's like 28 gauge, 30 gauge wire, really small stuff. But when you put a lot of it in a very small area, it adds up, and you want to make sure that you have an area, a compartment, some kind of plan to get it out of the way. Even if it's just zip tying things to the arms or whatever. But SpeedyBee has put this little compartment in the top, just above the all-in-one flight controller ESC, so that way we can put the receiver in there. It slides in real nice. It doesn't work exactly with this antenna, but it fits. It's just a little wonky. So that obviously gives us a lot more play and variability. We can add things later, but there's a little bit of wiggle room in the top there. Even if you're trying to save on weight, plan for a little wiggle room so you have the ability to adapt and change things out in the future, and it's a little bit easier to access in the meantime. The SpeedyBee frame is meant to go with the DJI O3 Air unit. I do not have that. I have the Walksnail Moonlight kit, so modification time. All right, so this front mount for the camera is meant to fit that DJI. The problem with that is that it's only meant to do that, and it was supposed to be compatible with the Moonlight, but it's the old version, and I didn't know that until I went. So here we are, 3D printing, coming to save the day. We can completely custom design a mount for the Walksnail, and because it goes to a custom frame, even if it had something like this, it wouldn't be mountable to our frame. So whole thing fits exactly the way we need. Printed it off. I think the whole process took 2 or 3 hours to get me a usable part for something that is not made anywhere else, and then instantly print it and have it in my hands. The second immediate problem with switching it out is that it's a 4-pin going to a 6-pin on our flight controller ESC all-in-one. So I jerry-rigged something really terribly, spliced some wires together because I couldn't make the pins. But if you look at the wiring diagram, it has the 6. The 2 that you need to drop out are the S-bus and the additional ground, because our Moonlight kit, our wiring diagram for that, has current, ground, receive, and transmit. So we don't need the S-bus and the additional ground. As much time as I spent on that camera 3D printed mount, I didn't actually end up using it because I didn't have the hardware that I thought I needed. So I ended up just cutting the old one and modifying it, but we're gonna go back and fix that and swap that out. So this is what it looks like. I mean, it's almost a finished drone, right? With the antennas, it looks great. It's got the snail look for sure. But now we can actually start closing this thing up 100% and put the finishing touches on it. I mean, this is a $1,400 drone done for $600. So it's clean, it's efficient. I mean, it just looks fantastic. Depending on the batteries you use, this even weighs less than 250 grams. So anyone can make this and fly this without having to be registered. And I think that's pretty cool. I mean, even as a hobby drone, this thing is great. At this point, once I started throwing the propellers on there, it didn't even feel real. I think it took me about 6 or 7 hours to do this. Probably more with the 3D printing and stuff, but I'd worked on this for a long time and a lot of planning went into it. And so to see the finished product, I was just really ecstatic, and knowing like what it's capable of, I was pretty proud. So final product, tell me what you guys think. I mean, can you do it better? Plugging in was a very different feeling because, like I said, it had just been so much work and so much hinges on this to start actually making income for this business and doing a whole bunch of other fun things. It was just a culmination of a lot of great things going on. Now for the unfortunate news. I turned it on, powered it on, was working on getting it configured, and as it was sitting on my desk with the battery plugged in, it just starts smoking, and internal malfunction caused it to implode. So that all-in-one flight controller ESC that I was talking so highly of, the one downside is that if it breaks, both of them break. So yeah, I have a replacement flight controller ESC on the way. New drone build happening. At this point, it's actually already done. So completely new idea. I mean, wiring's different. Everything's different. And then I salvaged and unsoldered all of the parts from the last one that you just watched. And I was so proud of. And you guys will see the next one from start. Well, from start to finish. From start to finish. So you guys get two for the price of one. And this breeds a lot of opportunities because I actually went ahead and got a 3D printer that can print carbon fiber. So we're gonna, that whole VTX not mounting to the frame and whatnot, I'm actually just going to create from scratch, new design, new frame, mounting for the camera, and I think it's gonna be a good opportunity coming from something so negative, especially since I have a timetable, I have properties to go shoot, I have wedding venue to go shoot, and I will talk to you guys all about this in the next week, because next week we are going to call up realtors, make a sales pitch. We're gonna start getting actual clients once we have a demo video from a working drone that we can show people, put up on a website. That's all going live like literally next week. So a lot of things going on. This drone needs to be finished. Tune into the next.